Previously we were looking at the learning rules, I guess, and I think we have implemented one of the basic gate using perceptron learning rules, right? Hebbian, sorry, my mistake. It was Hebbian, sorry. Hebbian learning rule we implemented, and we could understand that how the machine learns to classify the inputs of a AND gate, I guess. All right. Okay. So now we'll look at another example. So this makes things more clear. All right. So let's try to implement a, let's say, OR gate using Hebbian learning rule. All right, so we know that we have to make a simple table. The first uh, column including the inputs, and we know that we are going to use the bipolar, right? Bipolar types of inputs, right? So say this is x1, x2, and the bias. So we know that in this case we fix the bias to 1, all ones. Okay, there are four types of inputs possible. So first one could be 0 0. It's indicated in a bipolar format as -1 -1, right? Then we have 1 -1, we have -1 1, and 1 1. All right, so this particular column is for all the inputs. Then we know that the second column is related to the target, right? This target is denoted as y, and we know that in case of OR gate, OR is going to be false when both are false, right? So when both are false, both are -1, then only the target is -1. In all the other cases, target is +1. All right, then we will write the updation or in terms of the weight in the next column that corresponds to change in weight and bias. So that is denoted by delta. So how many weights you need in this case? It depends upon the input. So two inputs are there. So delta W1, delta W2, and delta B, right? Corresponding to the bias. And the final column we are going to write is the updated values of weights and the bias. Correct? So this is and bias. So this will be W1, W2, and B. So initial values are always 0 0 0, correct? So I think you remember that. Okay, so now as usual let's start with our regular calculation, right? So what is delta W1? So you remember the formula, right? Can you apply the formula and tell me the answer? There is an equation for delta W. Del Correct. So it's xi and yi, right? So just see what is the xi. X is the input. So first input into first y is the delta, correct? So first input is -1, x1 is -1, y is also -1. So we are expecting w1 to be -1. Yeah. Similarly, please calculate the other values. Delta W2 is x2 into y. Okay, W2 is 1. Delta W2 is 1, correct. Then now what's the equation for B? So you are doing the BI as okay, let me show the equation once. So this is y itself. Okay, so this y itself is delta bi. Okay, so bi plus 1 is bi plus delta bi. So delta bi is directly right like this. So now you tell me what happens to this now. So what's delta b? It's y. Just look at the y. What's y? Minus 1. So this is minus 1, right? Now w1 plus delta w1 gives you the updated value of the weight, correct? So d is 0. Sorry, minus 1 minus, sorry, I think I made a mistake here. This is plus 1, right? Just please verify this. Delta w1 is plus 1. Am I right? Okay. So this is 1 plus 0 is 1. Then what is w2 now? That's also 1. And what is 0 minus 1? The updated weight is minus 1. Isn't it? Okay, now give me the values of the second rows of delta w1, delta w2 and delta b. Take your time, you calculate and then give me the answers once you have it. Okay, this is 1, that's right, minus 1. Can you check the third one? What is delta b? Delta b is y itself, right? Delta b is equal to y, right? So just now you see previously what we wrote here. So this is 1. Okay, now add them to get the values of w1, w2 and b. Okay. 0, 0. Perfect. Okay, go ahead and calculate the third row values. Okay, minus 1, 1, 1. Okay, 1, 1 and 1. All right. Calculate the fourth row values. These are 1, 1 and a 1. All right. All right. 2, 2 and 2. So this means all the inputs which I'm supposed to give to this network we already have given, and the machine says that, the neural network says that these are the final weights, correct? So this itself indicates that according to this learning rule, the final values of the weights and the bias. All right, now if you remember, we have a specific technique to verify whether this is correct or not, right? So there is what is called as an equation, right? So the equation of, in a sense, whenever we say machine has learned something, this corresponds to a specific straight line being created by the neural network, correct? It's a linear classifier. So the straight line, according to the Hebbian learning rule, is denoted as x2 is equal to, do you remember the equation, minus of w1 by w2 times the input, first input x1, minus b over w2, if I'm right. Can you check this once, equation? Right, okay, so now let us substitute. We already have the values, right? So we know that from the above values, final values, w1 is 2, w2 is 2, and the bias b value is also 2, correct? Simply substitute. This implies the x2 is equal to minus of 2 by 2 times x1 minus, this is also 2 by 2, correct? So everything cancels, it's 1 by 1, it's 1. So that implies, what's the equation now? X2 is equal to minus x1 minus 1, correct? Right, so this means you can classify this problem. The machine tells us an answer that, okay, you have given me a specific target, right, for classification, and if you uh, plot those coordinates and draw this line, the line is this particular line can be classified as a classifier. That's what is the result. All right, let's just verify. Okay, so I think previously we did this once. Now also we'll verify. All right. So let's draw the coordinate system first, corresponding to these. Okay. So we know that first coordinate is x1. The second coordinate is x2. And we'll mark the points now. So this is along x-axis plus 1. This is corresponding to minus 1. This is plus 1. And let's assume that this is minus 1. All right. So the four coordinates will draw here. So this will be the first point, right? This point is, this is 1 comma 1, right? Similarly we can have this point itself as minus 1 comma 1, and the third point is minus 1 comma minus 1. All right, and we have the next coordinate, this is 1 comma minus 1, right? Out of which we know that these three fall under one category, and the other point minus 1 should be a different class. So now this straight line which we obtained by applying the Hebbian learning rule should be able to classify these two, right? 3 points on one side of the straight line, other 3 points should be on the other side of the straight line. Okay, now how to find plot this line? You assume that, let's make x1 equal to 0, right? When x1 is 0, what is x2? This implies x2 is equal to minus 1, correct? So one point is 0 comma minus 1. Let me mark that point. So where is 0 comma minus 1? X-axis 0, y-axis minus 1. I think that is this point, 0 comma minus 1. Similarly, let's make x2 equal to 0. When x2 equal to 0, what happens to x1? x1 equal to minus 1, right? So this is minus 1 comma 0 is the next point. So try to plot this. Where is this point? This is minus 1 comma 0. I think this is the point. Minus 1 comma 0. So now our intention is that we need to draw a straight line through these two points. So let me try to extend them on both sides. Right, very clear that this line classifies, right, uh, the given problem, and we know that we had two different sides and both the sides can be connected through this. Let's just recall what we did now, right? So we started from uh, this point. So we obtained the equation, right? So the equation was obtained as minus 2 x2 is equal to minus x1 minus 1. And in order to identify whether this line can classify our problem, our intention here is that we have to plot this line on the coordinate system and identify that where the points lie, on which side of the line the points lie. Okay, so just to identify that, what we do, we put different values to x1 and x2, right? So what I did now, initially I just put x1 equal to 0, made x1 0, which means x2 is equal to minus 1. That's one coordinate on one point on the graph, right? So that is 0 comma minus 1. You can see 0 comma minus 1 is plotted. All right, very similar to that. Now we make the other point. We try to find the other point by arranging x2 and x1 in the following way, right? We try to put x2 equal to 0. That's this x2 is 0, means x1 goes to other side. X1 is equal to minus 1. So that is minus 1 comma 0. We can plot it over here, right? So we got two different points on the straight line, means we can connect those 2 points by means of a straight line, right? So we simply connect, and when we connect we get this straight line, and it is very clear that the 3 points which should lie on one side of the line, it's classifying the 3 lines on one side, the other point, right, on the other side, like minus 1 and plus 1, right? So that means we are able to classify, right, the required problem of an OR gate, again using the perceptron rule. Anyway, we know that AND gate and OR gate are very basic, right? Definitely if you are able to implement that, we can use any other, right, complicated functions as well by using it, right? So okay, so that's the ultimate point, right? So now we, and whatever we understood so far in machine learning, and in case of neural network, the how the machine learns, right, I'll try to brief out now, right? So we understood that we just took one example of learning, that's all, and in that particular case the learning of ANN, or in general any machine, right, means what? You try to answer this question related to neural network only, because it can be generalized later on to any machine. Okay, but right now we have not studied any other machine learning methods or machine learning techniques, so let's not generalize as of now. So my question is now, when I say the machine has, sorry, not the machine, a neural network has learned something, means what? According to you, now you solve few problems, right? And you said that, okay, the neural network has learned how to classify the inputs, given input, to form a OR gate or to form a AND gate. Fine. So what do you mean by the neural network has learned something. What do you mean by that? Definitely, it means it is able to classify, right? The given event. That's the ultimate thing. But uh, with respect to the parameters of a neural network, what do you mean when I say the neural network has learned something? True, correct. So, what do you mean by that algorithm? Now you say I applied one algorithm called Hebbian learning rule. So, what is the result of that learning rule? What made the change, or what that particular learning rule changed inside a neural network is what I'm asking. So, it changed something, and because of that change, machine is able to classify. Correct? In terms of what it actually changed, you did some calculation just now, right? So in that change, what you got at the end results, so because you use the end results for in the example, in this case you can see 222 is the end result. What is that 222? True, right? So I actually have highlighted saying that okay, 222 is final values of weights and bias. So what exactly is that? Because you see, you started with 000 at the beginning. So now I don't see any input in my results. I don't see the output is also in my result. The 222 is actually completely different, and the 222 corresponds to some parameter of your neural network. What is that? What are the 222? I have written there, right? What is a 222? It's first two are the weights, and the last two is a bias. Correct. So only if you use the 222 over there, this particular neural network classifies your inputs into the appropriate classes. Otherwise, it is not. So it means machine. When I say machine has learned something, right? Machine has learned to classify something. It basically means, right, your machine is has learned something in terms of optimizing the values of weights and bias. Only when you have the optimum values of the weights and bias required to classify that problem, you can say that yes, machine has learned. Are you okay? So that's the answer to my question. When I say the machine has learned something, when I say, right, what do you mean by that? So it means, I can say this implies the updated. Definitely, it's going to update because we have some equation. According to the equation, it will update. So the updated, the weights and the bias, right, are, this is important, optimum. If it is not optimum, let's say that after the I'll go back to the same example we considered. So let us assume that at the end of this learning, right, the machine has learned something which is say 2 3 and 1. Let's assume, are they optimum? It's not optimum, right? Because for this problem what we are expecting is 2 2 2 or 1 1 1 or something like that, or 3 3 3 will even work. Okay, but if you have 3 2 1, definitely that is not going to work, right? You can see, if you try to make an equation like by using those values, right, you will never get a straight line which classifies these. In the sense, any other weights you get here are not optimum. Correct. So optimum values of weights and the what you call bias indicates that if you once you obtain that optimum value, it means machine has learned, the neural network has learned. So learning means it is updating the weights and the bias, not simply updating to a specific value. Okay, so that is the first point. Then let's come to the next one. So now I'll ask you a question and I'll give some time for you to think. Now see, this learning process might take uh, longer time or shorter time. Fine. So for example, this OR gate which we did, or the AND gate which we did, only 3 or 4 sets of inputs are sufficient for this machine to learn. Correct? You gave only 4 inputs. Machine has learned. Okay, but let's assume that you have a very uh, complicated problem definition. Classification is very difficult. Let's say I don't want to give a simple 1, 1, 1 minus 1. I want to give two images as input, right? Contains a chair and another uh, image contains table. Tables and chairs are the two classes, right? Now, you see that depending upon the size of the image you give, the neural network might take any longer amount of time, right? So neural networks might learn within say 2 hours how to classify. Some other algorithms might take say 10 hours. Okay, some other might take 2 days, right, on a computer when you run this through. Okay, so my question is that how do you what are the parameters that decide how quickly the machine is going to learn? Yes, machine in the case neural network in this case, right? So what on based on what parameters uh, we can control the way or the speed at which these neural networks learn. Okay, take your time, you can think and right, let me know once you have any answer in mind. Yeah, please repeat your answer once. Okay, inputs. You said this the speed of learning can be altered by you say was first one is input, right? Okay, fine. So how in what sense say in what sense this input may alter? Okay, so more number of inputs you give means more time. Is that what that's what you are saying? Okay. Yeah. Correct, correct, correct. That's obvious. That's obvious. That's a correct answer, right? Okay. So the first point was inputs. So the way of representing the input, or in other words, you can say way of presenting the input. Correct. I'll write that. That's a valid point. Very valid point. Right. So I'll just add one point here. So this is. I'll say I'll for quick learning. If you want to make the machine to learn very quickly, right? uh, all the first point definitely the way of we can say, as you told it, you can give simply number whole numbers like 1 2 3 or 1 minus 1 or something, or you can include the decimals. Definitely if you go for decimal places, right, real numbers, it's going to take more time because handling them will be a different way of representation corresponding to the machine, right? Okay, that's right. So I'll write that point as way of presenting the input. Correct. All right. Okay. Okay. Then you said about the second point. What was the second point? Can you come again, please? Okay. Wait. Weights and bias. Okay. Okay. Yeah. Please go ahead. Tell me in what way you think weights and biases are going to be uh, going to contribute to the speed of execution of an algorithm or speed of learning. Okay. Correct. So yes, you are close to the answer. Let's assume that instead of assuming 0 0 0, I assumed say minus 50, minus 100, minus 200. Let's assume, okay, because you can assume anything, right? Initialization can be done in any possible way, right? So for example, let's say, right? So let me say, so first case was simply 0 0 0. You started with 0 0 0, the weights, and it directly reached 2 2 2 quickly, correct? But now let's assume that instead of assuming a closer value to the, see, this is optimum, correct? Right. But this is initial, right? So initially is actually close to the optimum in this case, right? Let me assume that I took minus 50 plus 100 and say 300, something like this. You see how far is it to the optimum value, right? They're very far. If you point them on a three-dimensional space, 0 0 0 is close to 2 2 2 compared to the distance between minus 50 100 300 2 2 2 2, right? This is a huge distance. In the sense, machine is going to learn more. It's going to take more time to reach this point from this, right? So this is a longer distance, right? This distance is a short. So, in the sense, what you told is right. Definitely, the weights and the bias in terms of the initial values are going to contribute, right? How? It's the initial values will decide how much time it's going to take to come to the optimum time. So, for example, this is evident now. Already we have studied this. So I started with 0 0 0 and I came to 2 2 2 within two or three steps of learning. Correct? Learning in a sense, every time you give an input, it updates its weights and bias. So three times it did, and it came from 0 0 0 to 2 2 2. Fine. But now, if at all you start from this to come to this 2 2 2, right, the same four sets of inputs might have been given maybe 20 times. 20 times you give the same inputs again and again. So, right, so that kind of example we have not seen yet. I'm going to solve some problems later, right, which shows you that you gave these four inputs once, it didn't learn, no learning. I give the same inputs once again, you can see no learning. Again, that set you give again, then it shows some learning, like that. So the same sets of inputs you might have to give again and again to the same machine, right? Maybe after giving 20 times, it comes to 2 2 2 because your initial values are very far. Every time you update, it comes little bit closer, closer, closer. So from minus 50, minus 100, minus 300. So after first learning, it might come closer, say minus 25, minus 30, and plus 50. Later on, it will reduce to 10, 20, minus 30. Later on, it will reduce to 5, 5, minus 8, and so on. You see that it comes closer and closer every time. Okay, and ultimately at the very last stage, maybe that 20 is just a number. It's not, it may not be 20, it may be even 50. So you see that the learning is very slow in that case, right? So again, after that, what else do you think? Is there any other point? So first one is right, the way of presenting the input corresponds to the speed of that. And you told about the initial values of weights and bias. I'll write that point as well now. Okay, and keep thinking, is there any other thing that you can use or that might contribute to the speed of operation of learning process? All right, so this was the second point. This is initial value of weights and the bias. Perfect. Number of times, can you repeat please? Huh. Correct, correct. So number of times it is going to run. Basically, I think we covered that point in this itself. Initial values are very far away from the optimum points, means it will run. It will run more times. Okay. If you give an initial value very closer to the optimum value, right? It will run less time. So there itself you have a control over the how many times it's going to run. Okay, I think that point already we have taken care of by writing the initial value of weight and bias. What about the algorithm? Because so far we studied only one, that is a Hebbian learning rule. How the machine learns, we understood. What if there is another learning rule which is much faster than this? Very less amount of calculation compared to this. If you have something, will it matter? Correct. So selection of algorithm also should should give you some inputs related to how quick it's going to learn, right? So neural network is still same, but the algorithm you choose, right, might have to do something definitely about the learning process, right? So yes, then think about, do you have any other options? Okay, so I'll simply write the learning rule or the algorithm. Okay, yeah, you can think of, we may have many other solutions coming up. All right, there are multiple ways, but anyway, we understood whatever is required as basics. All right, so now I'll give you some questions to solve by yourself. It can be taken as homework. All right, so the first question is this: apply the rule to classify following images. So images in the sense it's not, and anyway, we cannot give photos as input, so we don't know that. We don't know how to represent them and how to give that. So it's an image. It gives you an idea how the practical things are going to work. Okay, so that's why I term it as images. All right. So let's assume that these are the two images. So each image is a 3 into 3, right? There are 9 pixels in each image. So each block what we see here, right? Each cell is a pixel, right? Now I want to classify. Okay, before that, let me copy this once again because I want to have two images. Okay, so these are the two images which we want to classify. Fine. Now let's see what is the image content. Content of this image is like this. So there are some colors given. So colored region is what there is difference in terms of the colored regions of the two images. So first image is colored in this fashion. So these cells are colored. Okay, sorry. Also, there is a coloring of this region. This is also colored. Okay, it's like an eye. You can see an eye over there. Similarly, in the second image, that's also going to look very similar, but there is a small difference in the pixels or in the regions where they have done the coloring. Okay, they have done the coloring only for this region. So this is something like a J for you. Okay, if the first one is I, second one is J. So the question is that you have to develop the learning rule, in a sense, ultimately obtain the final weight values of weights and the biases such a way that, right, you are able to classify when I is given and when J is given. So how do you give the inputs now? Let us assume that if there is a color, you call wherever the color is given, right, that is a 1 for you. Correct? So let's assume this is as an example. Even you can change this the way of representation. For me, this is 1 1 1 0 1 0, or 0 can be even -1, because anyway we know that we are using the bipolar format, right? So this could be -1 for me. -1 1 -1 1 1 1. So when you write it in the in a linear fashion, like this is input. So first one is x1, x2, x3, then x4, x5, x6, x7, x8, x9. So how many inputs you have? 8 inputs, 9 inputs you have. So previous problem had only 2 inputs, correct? Now the inputs are how many? 9. There are 9 inputs. So I'll just write here for your reference when you solve. 9 inputs starting from x1, x2, dot 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 up to x9. Right? So colored pixel indicates that this is +1. Right? So you can see that, right? Sorry, not 0, my mistake. It is 1 1 1. So at the same time, on the other for the second class, you can see that 1 1 1 -1 1 -1 1 1 -1. Okay, so non colored, this is -1. So now you see the class 1. What is the output for class 1? When you give I as input, what do you expect? No, it's class 1. Your machine will say either +1 or -1, right? So you can say that when I give I as input, I am expecting +1 as the output. This is the target, right? This is the target. So target Y is equal to 1 for the first case, and plus this one J is given as input. This means -1 is the target. Are you okay? So now you can imagine it's a just simple the same question which we solved earlier, but the table is going to be very big. So inputs are x1, x2, x3 up to x9, and a bias, correct? Followed by you have delta w1, delta w2, dot dot dot, delta w9 and delta b, correct? So this is the next column, right? And on the right side, after that you write the values of the weights, that is w1, w2, dot dot dot, w9 and b. So this itself is what has been asked. Okay, so you give these inputs and find out what is the final values of weights and bias. That's the question. All right, so it's actually something like very very practical problem. You can see that, right? So you are trying to classify not some very simple and or gates or something. You are actually trying to solve something practical, right? You are trying to classify I and J letters. Again, they are very close enough, right? So something like very practical.